All right, guys, so this is where it gets a little bit more complicated in terms of equilibrium, and it's a good idea to review this. So this is actually a quite complicated question, although it looks pretty simple. So they're telling you you have this reaction down here that I rewrote down here. So we have 2 moles of gas turning into 1 mole of gas. So what happened in the experiment here is they started with an original equilibrium, and I'm just going to say that's 1 liter. And then they changed the volume, and it looks like about half, so I'm just going to call this half a liter. You're starting with 3 molecules of PCl5. You happen to be starting with 3 molecules of Cl2 and 3 molecules of PCl5. So that's just what you happen to have in your equilibrium system. Okay, so the question is, what happens after the volume change and when you reach a new equilibrium? So remember, pressure and volume are inversely related. So if you are decreasing your volume, you're increasing your pressure. So because this system, you have 2 moles of gas on one side and you have 1 mole of gas on the other side, when you decrease the volume or increase the pressure, it's going to shift the system to the right to make more products. Now that would be kind of a simplified version. Because we're in AP Chem, right, we have to take it a step further. So what we're going to do is we're going to write the Kc. So remember, when you write the equilibrium expression, you write the concentration of the products. Remember, only if it's a gas or aqueous. You don't do this for solids or liquids. Divided by the concentration of the reactants. And again, remember, if we had a subscript, or I'm sorry, like a coefficient here, then that would be cubed, right? But we don't have any coefficients, so we don't have to worry about that. Okay, so what I'm going to do is I'm going to solve for Kc. So because I have 3 of each, right, that's how many moles I have of each one of them. When I'm finding molarity, it's going to be moles over liters. So I have 3 moles, I'll just count that as moles, over 1 liter. So in this case, my molarity is 3 molar. So each one of these has a molarity of 3 molar. So 3 divided by 3 times 3 gives me 1/3, which is 0.33. So regardless of anything going on, I'm just going to erase this, other than a temperature change, the only thing that will affect Kc is temperature. Since there was no temperature change, my Kc is locked. It's going to stay at 0.33. Okay, so what they did was they stressed the system and they increased the pressure and decreased the volume. So the stress, because I have 2 moles on one side, right, the stress is going to shift it to the right like we talked about. Okay, but let's talk about a Q. So Q is the reaction quotient. So that's at a moment of time. So if I look at my Q, it's the same exact setup as my K, right? So it's PCl5 concentration over PCl3 times Cl2. However, because my volume has halved, my molarity is going to change, right? So if I do a molarity of each one of these, I still have 3. If I look back at this system right here, there's 3 of everything. So my molarity is 3, my moles are 3, and my volume has been cut in half. So now I end up with a molarity of 6. So each one of these is going to be 6 molar now. So if I plug that in, I end up with 6 over 6 times 6. I end up with 1/6, which I have to do, but I think it would obviously be half of, yeah, there we go. It's Saturday morning. Give me a break. Okay, so my Q is 0.17. So the summary here is that because my Q is less than my K, so 0.17, a moment of time is less than where it wants to be, the system is going to shift to make more products so that this gets bigger, right? And then my Q becomes my K. So the answer to this one is you just had to draw more PCl5s than what was here. So if you drew 4 of those or 5 of those, and then you had to make sure that conservation of mass worked. So say you drew 4 of these, you would have to reduce these just so that you make sure you have the same amount of like clear circles, which represents chlorine, and shaded circles, which represents phosphorus. The last thing I want to mention is what happens if they, inject a gas in here. So if they inject a gas in here, so say they inject something, a noble gas. So the thing you need to know about noble gases is they are very unreactive, especially the higher they are in the reference periodic table. So like helium, neon, argon are very unreactive. So if you injected that in there, your partial pressures of everything are going to change and your Kc is going to remain the same. So if something like that happens, it has no effect if it is a non-reactive gas. Another non-reactive gas, unless it's part of a reaction, is nitrogen. So nitrogen is very inert or unreactive. If you go lower on the periodic table, the noble gases, some of the lower ones can react because their valence electrons are so far away from the nucleus. Okay, hope that helps. Have a good Saturday.